Okay. Excuse me. Hi, folks. Welcome today. My name is John O'Reilly. I'm a software engineer living in Galway in the west of Ireland. Work remotely for a company called Neat, based up in Oslo, and it's an absolute pleasure to be here in person today talking to you in Berlin. So, the plan for today is to talk about the combination of Kotlin Multiplatform, GraphQL, and Declarative UI. So, a pretty broad scope of technologies. And I hope at least, it's going to be somewhat of a whirlwind tour, but I hope at least people will come away with, if nothing else, a flavor of what these technologies are, the capabilities they provide, and what a compelling combination I think they are together. I'm going to go through a couple of slides at the start, just to give some overview and context, and then we'll jump into a live coding session where we'll build out the solution. And I'll take the opportunity when I'm building out the code, obviously, to add some additional commentary to what I'm doing and to the technology we're using. Hopefully be some time at the end for questions, or reach out to me directly, of course. So the first up, Kotlin Multiplatform. You've probably seen a few other talks today about Kotlin Multiplatform. But just to sort of level set again, it's typically about the ability to run Kotlin natively on a range of platforms. It sort of differs from other approaches like cross-platform frameworks in that it's typically targeted. It provides this optional code sharing that critically supports sort of the incremental adoption. You've heard other people, as in the other sessions, talk about the fact that how it was possible to incrementally adopt KMM into their projects. It's typically focused on the sharing of non-UI code, and critically, it provides access to sort of platform capabilities from the shared code as well. This is a quote I usually show from Kevin Gallagher from TouchLab. If you've been looking into Kotlin Multiplatform at all, you're probably very familiar with Kevin and TouchLab, sort of pioneers in this space, and it's sort of succinctly, it's probably the most succinct definition I've seen of Kotlin Multiplatform. And this section at the end in brackets is something he actually recently added to this quote, which is sort of just emphasizes the fact that this is something that is backed by JetBrains and very much, and you might have seen in the JetBrains event yesterday, sort of the comment about obviously their continuing commitment and building out of support for Kotlin Multiplatform. Another thing, I think Enrique mentioned this, I think, in an earlier talk, but what sometimes causes confusion, just showing this here at this point, to when you hear about KMP and KMM. Kotlin Multiplatform, KMP, is, I suppose, the broad capability to run Kotlin on, as I mentioned before, on a range of platforms. KMM is, on one hand, a sort of a rebranding by JetBrains, really focusing on this key use case of sharing code on iOS and Android. Comes with updated guidance and samples, and as we'll see in a moment, there's a nice Android Studio and app code plugin that you can use to generate a KMM project. Next up in the sort of whirlwind tour, GraphQL, a little bit hard to describe in a single slide, and obviously as we build out the code, hopefully you'll see, if you haven't used GraphQL before, you'll see some examples of it, and it'll hopefully make it clear what it's about. But this is the definition of it. I mean, it's fundamentally a query language for your API, and of course there's a server component of this, and the server component is important in that it supports the querying of the schema of your content. Then when you're using a client library like Apollo, like we're using today, the client libraries like that can retrieve that schema and generate this strongly typed code for the queries and the data model associated with that. It's seen as sort of like an evolution of REST to some extent. Some people, I think, have described it as REST on steroids. You can tailor exactly the data you want to get back, and that typically implies that there's less queries required, which obviously on a mobile platform is advantageous. What it's sometimes described as in the context of, along a similar vein, is this ability to avoid under or overfetching. This is the Apollo. This is the library we're going to use today, Apollo. It describes itself as a strongly typed caching GraphQL client for the JVM, Android, and Kotlin Multiplatform. And this caching aspect is very important. I mean, what you get here with Apollo is not just the ability to make requests to your backend, but also to cache the data locally. So you get this all-in-one capability that's very powerful. And then when you couple that, obviously, then with being able to run this code in shared code on iOS and Android, I think you can see how powerful that is. It comes with the Gradle plugin, which we'll be making use of in a little while to sort of generate code from the schema. And this is an example that if you haven't used GraphQL before, what these GraphQL endpoints typically support is this sort of web UI, this GraphQL, this playground UI that we'll actually be making use of later on. And this is a very nice capability that allows you to sort of browse the schema, browse the queries, try out your queries, for example, as we will here, and then sort of pull that into Android Studio in our case and generate our code from that. The last of the three major technologies, Declarative UI, a ton of talks, obviously, these few days around Jetpack Compose, and a lot of Android developers here are probably very familiar with Jetpack Compose. But when we talk about Declarative UI and Compose, as I said, on Android and SwiftUI on iOS, what we're talking about typically is the what versus the how. What declarative UI is about what your UI should look like in a particular state. And any changes in state then cause the appropriate parts of your UI to be updated. And this is seen as sort of contrast to sort of imperative type approaches where you describe, what step by step what your UI should look like. A small bit of history. Jetpack Compose was announced at Google I/O in 2019. I have to admit, I saw that at the time, and it didn't really. It was at a very early stage of development. That stage didn't really trigger what this was about. And then, about 3 or 4 weeks later, I was watching WWDC in 2019, and SwiftUI was announced. It was at a much more advanced stage of development at that stage. I was able to download an Xcode beta that evening and try it out, and it was sort of immediately clicked about how approachable UI development becomes when you're using a framework like that. And I think this is the experience, obviously, people are having today with trying out Jetpack Compose for the first time. This is just a quick screenshot. The talk today is based on a repository I have in GitHub called Star Wars, where actually it shows not a particularly complex UI, but it shows sort of a list of actors, or not actors, but characters rather, and films. We're going to focus in on films just to keep the scope manageable for today's talk. And just before we jump into code, even just at this point, again, I'd say a lot of folks have probably seen Jetpack Compose that are in this audience here anyway, but just to give people a flavor at least, this is coming from the code that we'll be writing later on. Typically, our Jetpack Compose is really just about Kotlin functions that are annotated with composable, and where you pass in a piece of state. And in this case here, the film state is actually going to be something coming from our shared code. And then if we look at the SwiftUI code, then in contrast, it's using Swift structs versus Kotlin functions. Some of the keywords are a little bit different, but it's fundamentally the same approach. And the film class that we're using here is the same film class we're using in our Jetpack Compose code, for example, that will be coming from our shared code. This is the Star Wars repo that I mentioned earlier. I have a range of samples in GitHub that exercise a range of different Kotlin Multiplatform libraries. There's one other one, this one that uses GraphQL. If people are interested in sort of trying this out a bit later, digging deeper into this sort of combination of technologies, this one takes a little bit more, somewhat more enhanced UI, I guess you could call it, and utilizes sort of the paging support of GraphQL and the paging support that Compose supports as well, which is very nice. And this is what a very high-level architecture diagram for what a project like this would be. Obviously Swift and Kotlin. We have our shared code here. We're using our repositories. In today's example, very basic example, we're going to expose our repository from our shared code that obviously interacts with the GraphQL server, and we have some shared data model. You may or may not use a view model. Most of my samples in GitHub use a view model. Today we're going to use the repository directly, just given the scope of what we're doing. There's nothing about KMM, and this was mentioned in earlier talks, that really forces you to use a particular architecture. A common case, I think Lena mentioned earlier, and Enrique as well, in terms of if you have a clean architecture and you have a use case interactor, that could be in your shared code. There's a number of different approaches in terms of the view model, whether the view model is in native code or shared code, or even straddles the two, which is another example I saw recently. OK, so I said it was a whirlwind tour, so we're going to hopefully get out of this. OK, so whoa, OK. Let me just resize this a little bit. So the first thing I suppose to mention is, if you're starting off a Kotlin Multiplatform project for the first time, there's a range of different approaches that you can take. I mentioned that part of KMM was this Kotlin Multiplatform plugin for Android Studio and for app code as well. And that gives you the ability to sort of create a new project. What you're going to get out of that is an Android application and an iOS application. It gives you a couple of options in terms of the sort of what you might call the plumbing approach, what we ultimately want to do with our iOS code in our shared. What we're going to have is a shared module that is available at both iOS and Android, and we want our shared module to be built as a framework then that's consumed on iOS. And there's a couple of different approaches. What's described here is a regular framework or CocoaPods. The other approach, I suppose the other thing that was touched on in the earlier projects in terms of people's experiences starting up with KMM for the first time and struggling with different dependencies and Gradle configuration and so forth, is definitely recommend not starting from scratch. Use the KMM plugin that's available now. There's a range. If you know, for example, that you're going to be using a GraphQL or you're using a REST API endpoint, and in that case you're using Ktor maybe, start with a sample. There's a number of samples out there that use the particular sets of libraries. So I definitely recommend sort of putting those down. So what we have here then is a shell of a project that, for example, we would have created with the KMM plugin. We have our Android app module, we have our shared module, and we have our iOS application, for example. And in our shared module, if we look, for example, at the build file, hopefully this is coming through OK. Yeah. What we see here, for example, is that we have a multi-platform plugin that we're using. This is what you get sort of when you create a new project. We've also added in the Apollo GraphQL one, which we're going to be using obviously today to do this supports a number of Gradle tasks for code generation, and as we'll see in a moment, for pulling down the schema from the GraphQL server. And then you get the ability to sort of find different source sets. So you have something typically like this, where you have a common main where all your sort of common source code is going to be, and that's where you ideally want most of your code to be. And in fact, in today's talk, that's where all our code will be. But you also have the ability in Kotlin Multiplatform to sort of override, to provide platform-specific capabilities, and this is where the likes of Android main or iOS main allow you to do that. For example, if you're using SQLite, then the way you set up your database driver, for example, needs to be done in a platform-specific way. So you would write some code in Android main and iOS main for that. But in today's talk, so pretty basic. We're using Kotlin coroutines. We have the Apollo runtime dependency. But other than that, this is a standard KMM project that you would get, as I said, if you created using the plugin. So the first thing we're going to start with is we're going to use one of Apollo's tasks, download Apollo schema, to hit the endpoint. We're using this endpoint that provides data about Star Wars movies, films, and we're going to retrieve the JSON from that. So if we run this, that thankfully works. And then we'll see then we've pulled that down then, and we have a schema.json file here. I also have an empty queries file here. So what you want typically in a GraphQL project is you'll have your schema like that, and that describes the data that you're going to be, the data model that you're going to be dealing with, and then you have a set of queries that you want to use, and then the combination of those queries and that schema.json file are Apollo generates source code, strongly typed client source code from those. So before we do that, I'm just going to tab over to. I mentioned about this sort of playground UI that GraphQL provides. And what's nice about this is that you can browse your schema, you can browse the queries that are available, you can try out your queries, and then, as I said, you can pull that query then into your App Studio and then generate code from it. So in this particular example here, we have get all films. Let's run the query here. OK, this is the data we're getting back based on. The other thing to note here is we're getting back only the data that we requested, and we'll make some changes to this in a little while. But that's another key thing to get across here, of course, is that you don't under or overfetch. You get exactly the data back that you want. And just to point out again, we're sort of using a GraphQL sort of concept here called a fragment, and that sort of allows us to take the results of our get films is going to be a sort of structure with all films, and then for each film, something represented by this film fragment. And we'll see in a moment that then gets generated into a Kotlin data class then that we can interact with in our shared code. So let's copy that. Put this in here. And now the other thing to point out here is there's a nice Android Studio plugin in turn, which allows you to actually run these queries directly from within Android Studio. So if we run that there, and it comes up pretty quickly, we get back that same data that we saw in the Explorer, for example, which is quite nice. So again, another level of sanity test that the query you have is structured correctly, that is returning the data that you want. So at this point, I'm just going to run the generate Apollo sources Gradle task directly here. This would normally be run as part of a build, but I'm running it here just to show you something in a little while. And let's start building out some code. So very basic application. We're going to have a repository class in our shared code. This repository is going to be built for both iOS and Android, and used obviously in the clients and on those two platforms. So let's start. So again, to sort of save you watching me mistype a lot of code, I'm going to make active use of Android Studio Live templates and code snippets, I think they're called on Xcode. But as I pull in the code, then obviously use it as an opportunity to add some additional commentary. So the first thing we're going to do is add in our basic film model. And what we have here is, this is, the sum total of our domain here. We have a film which has an ID, a title, and a director. This film fragment then is something that's actually was generated by Apollo. And if we click into that, we can see that this is a data class that was generated from that fragment. If I go back to here again, this maps to this film fragment that's coming back in the result of our GraphQL query. And you also get this nice comments as well. So the comments are included in the schema, and then those comments are added as part of the generated code, which is quite nice as well. So let's add a basic repo. OK. And that's something, the Apollo client then. So we're going to interact with this Apollo client class that Apollo obviously provides. We're passing it the server URL, the endpoint we're dealing with here. I'm a little paranoid in talks like this that the server I'm trying to reach isn't going to be available during the talk. So the repo actually includes a sort of a back-end module which simulates the GraphQL server. So I have a sort of another URL here that kind of would hit that. But thankfully, it looks like we don't have any issues today. We're going to add in a method to get the list of films. And we're using, again, this is all generated code by Apollo. This get all films query was generated from, if we come back here again, this get all films here. We're getting the data back, and we're navigating through all films. And again, that maps to the data structure that we're querying in the GraphQL query. And this is a suspend function then that returns that list of films. Now, before I move on from here, I'm going to add something for iOS as well. And this is a segue to sort of a broader discussion that we're probably not going to cover in a lot of detail today. But the options available, and this was kind of touched on in some of the earlier talks, the options available for calling Kotlin functions in shared code like this from iOS, and there's a range of different options. Traditionally, the only option really would have been to use a completion handler like this. In fact, what we're going to use today, just for simplicity, where you pass in a completion handler or a lambda from your Swift code, and then you use some scope, some main scope in this case here, and then we call the other getFilms method, and then obviously return that. Kotlin 1.4 added the ability to call suspend functions directly from Swift, Objective-C. So that's another option. It comes with some caveats in terms of things like the scope used, the cancellation, and so forth. Another very interesting option that's becoming available is this community library called KMP native coroutines. I'm not too sure if folks have come across it. And that provides some very nice mapping, not just for sort of standard Kotlin and flow, but also to sort of the evolving ecosystem within the Swift world in terms of things like traditionally Orex Swift or combined publishers, for example. And now, as with Swift 5.5, we have things like async await, which is very similar, obviously, to suspend functions. And I think it's called, I can't remember the equivalent to flow, but async something. But that's a very nice library. Again, if this is something you're sort of digging into in more detail, definitely recommend looking at. But for now, we're just going to have a simple method here that we're going to call from our iOS, which is going to be hosting a lambda or completion handler. So one thing I didn't mention back in the build Gradle file is that part of what the Kotlin Multiplatform gives you is the ability to target, obviously, different platforms. We're targeting Android, iOS. We're going to create a shared module here, a shared framework from iOS. And we've also added a JVM module here. And the nice thing about the JVM module is then within my JVM main source code, within my sort of common module, I can add a sort of simple sort of main function here. And it's a nice thing to do as a sort of initial sanity testing as you sort of build out your repository. And before you work on the UI, I mean, obviously, you would potentially write unit tests here as well, but even just to have a simple main function like this that we can call. And let me run this. And there we go. We're calling that Star Wars repository class that we created. We're getting back the list of films, and we're dumping them out here. And this can be extended, actually. It's quite interesting. If you've been looking at Compose, you may be familiar with the work going on around desktop. Compose for desktop, for example, obviously runs on JVM as well. So another interesting sort of variation of this I've seen people talk about is even if you're not targeting Compose for desktop, using Compose for desktop as a way of sort of prototyping and trying out some of your Compose code before you sort of build it into your Android application as well. It's just another option. OK, so we have our very sophisticated repository here. It's going to get the list of films. So let's write some Compose code. So again, I'm going to use this code snippet. So we'll start in, I guess what you typically have here is sort of like a tree of nodes in our UI nodes or UI components. We're going to start sort of at the leaf here, which is something representing our each row in our list. So it's very standard Android application with a list, and each element in the list is represented by a row here. So this is a composable function. We're passing in film. That film class is the film class that we wrote in our shared code. We're using Compose's list item here to show a list with sort of text and secondary text. And then if we go one up in the hierarchy, so to speak, if I can type correctly. we have our list then. And so we pass in the list of films. And I guess to get across again that this concept of state and rendering UI according to state. So our film view, this is what our UI is going to look like for this particular piece of state, which is the film. This is what our UI is going to look like for the list of films. And the comparison again, I might touch on earlier, is if you've come from sort of traditional Android development, this is what a recycler view would have been before. You would have had a recycler view, you'd have an adapter, you would have view holders, you would have your layout files and so forth. This is the sum total of what you need in Compose, which is obviously very powerful. Let's add something for our layout, or our screen as a whole. Just think of this as representing our overall screen. This is sort of a nice segue to a couple of other things. We're not, this isn't a sort of deep dive on Compose, but just to highlight a couple of things. With composable functions, they can be invoked at any time. You try to make them as free of side effects as possible, as stateless as possible. So this remember, for example, gives us this capability to create the Star Wars repository one time on the initial sort of composition. And then we're using our Compose's produce state extension function. It provides a capability to map to sort of non-compose to compose state. When we talk about Compose interacting with state, it's its concept of state. So this produce state allows us to call the suspend function, which is this repository class to get films that we added a little while ago, and that then is converted into compose state. And then when that state changes, then the compose runtime, I guess the magic of Compose to some extent is that it knows what parts of the UI, what compose functions have, or what parts of even a compose function have accessed that state and need to be recomposed, need to be relayouted again. And lastly, at the top of the hierarchy, so we have our activity. This stage is standard Android activity, and in a Compose project, you'll typically have one of these, which is sort of representing your initial plumbing to sort of set up an activity on Android. We're using instead of set content with a layout file, as we traditionally would have done, we're using an extension function where we can pass in a composable. We're using sort of theming. When you create a new compose function, for example, in Android Studio, you get this very nice theming support, so your typography, your colors, and so forth. You can customize those. And here we invoke our main layout. So let's see if we can run this. OK, great. We have our very sophisticated UI here. So we're going to make it a little bit better, but hopefully, even at this point, we've got to a point where we have sort of a lot of the key moving parts in place here. At least on the Android side, we have a shared code module that has a repository. It's going to be built for both Android and iOS. We've added some Compose code, and we're obviously accessing that repository from the shared code. Let's make the Compose a little bit nicer before we move on. Instead of film this here directly, I'm going to use Compose's scaffold. So this is another nice thing, Compose thing, which kind of gives you something to represent your screen as a whole. Here we're adding a top app bar. The version in GitHub, for example, has a bottom navigation as well to navigate between the films and the characters. So if we run that, OK, it looks marginally better. At least we have a title bar here. OK, before I go back to so we're going to go make some changes to our query in a little while. But just before I do that, I'm just going to switch over to Xcode. And this is, again, when you use something like the KMM plugin, you'll get an Xcode project set up for you. And that Xcode project is set up with the appropriate plumbing to ensure that the Gradle module that we were working with a moment ago is built, and the resulting artifact, a framework in the case of iOS or an Android library in the case of Android, is sort of integrated in and built as part of your Swift or your iOS build. So in a similar vein to our live templates on Android Studio, we're going to use code snippets here. We're going to put in our leaf node again here, and this is a film view again, something representing the row in our list here. As we touched on the slides earlier, some different syntax. We're using structs, obviously, versus functions. Some different elements here. HStack, VStack. In Compose, you might use something like row and column. Text elements are the same, slightly different approaches to styling. But hopefully, if nothing else, to get across, again, this sort of the fundamental similarity in approach between SwiftUI and Compose, which I think is very powerful. Let's move up. Again, similarly, we'll move up the hierarchy, so to speak. We have something representing our list. Again, we have a list of film list. And you see here we're importing shared, and that's our shared module coming from our shared code. And as such, we have access to. So this film class and this list of films, these are the same film classes that we were interacting with in Compose that we were accessing from the shared code there as well. And lastly, if we move up the top layer, again, we have something representing our screen as a whole. Concept of dealing with state is a little bit here. We're using @state here. how we the approach to navigation is going to be obviously a little bit different. How we show the title bar. We have a hook here on up here where this is where we call into our repository to get back the list of films. But similar to Compose, once that film list state changes, then that part of the UI is recomposed, relayout to reflect that. So let's run that. And while it's running that, let me just switch over to another view here. So this is, if you kind of look under the hood a little bit, when I said when you create a new KMM project, some of the plumbing is set up for you. This is sort of what goes on under the hood. There's a run script is added, and it invokes Gradle with this. Okay. Sorry. I'm gonna get, yeah, strange. I don't know. It was fully charged up. Sorry about this, folks. Let me just. Have you? No, it was charged up before. Let's see. Can I? Have you? Can you plug this in somewhere? Okay. It's going to work. It's going to be OK. Yes. Yay. OK. Let's. Thank you. that definitely gives me a chance to get some water. So sorry about that, folks. But so where we're talking about Xcode and the plumbing that's set up automatically for you. So that the idea then is that when you build within Xcode and you build a project, it will delegate out to this Gradle task and run that. And in terms of build speed, I guess experience differs here, but typically if you haven't made changes in the shared code, that task should return pretty quickly, and that's been my experience here as well. So sort of as a UI developer, focusing on a SwiftUI where you have some shared code, and once you build it that first time, and if you're not making any changes to that, it shouldn't have really much of an impact on your overall sort of make a code change, build, try out cycle, for example. So while that was building here, and this is our SwiftUI our iOS application, as equally sophisticated as the one we had on Android. OK, so let's switch back to Android again, and I'm going to just make a couple of other changes. So one thing about, we talk obviously about GraphQL and the fact that GraphQL, you tailor your query to get back exactly what data you want to get back. So in this case here, if we switch back over to this playground UI that we were trying out before, we can see obviously we were looking for title and director. So we can see the other thing this provides is the ability to browse the data. So we can see, for example, that there's a release date here. So let's add the release date to our query. And you get auto-completion here, which is quite nice. Now, if we copy that release date into our query here within Android Studio, we avail of the Android Studio plugin here to just sort of run that again, do a sanity test. And we can see back the release dates coming back here as well. And if I go into my repository now and I just sort of update my class here to add that release date, and then we update our extension function that maps. This because I probably didn't. That's the trouble with me. There's a reason why I don't type code. Why am I? Oh, sorry. What? Oh, yeah, probably. It should still. Let me just see. Run this. It could very well be. Apologies. Yeah. Yes, thank you. Someone's paying attention. And that's a good segue, thank you, for going into Film Fragment and just seeing our generated code here, and the fact that obviously our generated code now contains the release date that we needed to obviously do the regeneration for to see. And you obviously get the commenting coming back, the comment that comes back as well as part of that, which is quite nice. So we have our Star Wars repository. We've updated our data model a little bit, in our class to map to it. Let's just make a little bit of changes to our our Jetpack Compose code. We'll just update the UI a little bit. Instead of just showing something like film title here, we now have access to the title and the release date. So we're going to add in the release date, the title, and the release date. And if I remember, switch back to Android app here. And you get the title and the release date here. So nothing overly sophisticated, but again, I'm trying to sort of get across here, I guess, what are the key moving parts here, and using sort of a small example like this to do that. We have a Kotlin Multiplatform project. We have a shared module, obviously, where a shared code that's going to run for both Android and iOS exists. Android application, iOS application. In our shared module, we're using Apollo GraphQL, the Apollo GraphQL library. And what that's giving us is the ability to sort of, with the sort of downloaded schema for the data and with our own particular queries, to generate strongly typed client code for that we can then use in the shared code like we've done in our repository here. And that code is obviously then, those functions are then available obviously on iOS and Android, which just said is very powerful. And then we have some basic Jetpack Compose code. And again, hopefully this gets across as well that there's a very nice sort of delineation, sort of separation of concerns here. We're dealing obviously with a repository. Maybe, as I said before, if you're using clean architecture, you'd have use case interactor layer there perhaps. And then in our UI layer there, whether we use a view model or not, or depending on where we put the view model, but you have that clear separation then. And as a UI developer in Compose like we have here, or in SwiftUI as I have over here, for example, we have this API available to us from our shared code that we can make use of, and iterate then on our UI around that. And that was it, folks. Thank you.